Now, question 10. This time, we have multiple triangles in the same diagram. That makes things a little more challenging. But you need to understand that we need to identify all the right angle triangles in this diagram. So how many right angle triangles do you see? This diagram, there are two of them. 1 and 2. So you view the triangles separately. If you need to, draw them out separately. Okay, so we got a vertical height of 48 meters, 2 cars, same horizontal level. They tell you it's the same horizontal level, so that we are going to end up with a nice right angle over there for both triangles. So AT, wait, what? Cannot tell. AT is 88. Where got T? Oh, AT. Oh, the diagonal. Okay, this diagonal is 88. And then BT is 60. BT 60. And we've got the vertical height. So for both of these triangles, we can actually find the horizontal distance already using Pythagoras theorem. Now, they want us to find the distance of AB. Oh, very faint, huh? AB meaning this distance. So use your Pythagoras theorem, find out the total distance from A to the building, B to the building, and then subtract, you get the answer. Only one concept involved, Pythagoras theorem. So I want you to take note of the way they present it. They left the answer AF as well as BF in the square root form. What if they don't leave in a square root form? What if they use calculator to press, get the answer? If you put your answer in 5SF, you are not wrong. It's just that it's not the best answer because it's not exact. 5SF, it's not wrong. And then if you use 5SF to minus 5SF, you will get an answer which is again not exact. But then from there you round off to 3SF, you'll be fine. But the best way to do it is actually to use the exact answer. Only at the final step, then you use your calculator. Finally, round off to 3SF. Okay? So what happens if in the intermediate step you use 3SF? If you use 3SF over here, 3SF, then 3SF minus 3SF, your answer may not be 3SF. Even if it is 3SF, it is a coincidence. Okay? How high are the chances of getting the correct answer? 3SF. If your intermediate steps, you use 3SF as well. I don't know. Depends on the actual values. But you wouldn't want to do that because you'll still be penalized for your accuracy. So general rule is that we always want to use as exact as possible. Only at the final step, then we round off to 3SF. So question 11, length of diagonal of rectangle. Okay, so here, because it's a rectangle, we're going to end up with triangle triangle when you draw the diagonal. So that's 41. They tell us that the width is 9, and then find the area of the rectangle. So area of rectangle, we only know one way to calculate it. Length times breadth. In this case, the breadth, 9, given to us already, I need the length. So the length can be found using Pythagoras theorem again. So you see this over here is a variation. Basically, there are 2 steps that are skipped. By right, we should be starting off with, x squared plus 9 squared equals to 41 squared. And then after you have x squared equals to 41 squared minus 9 squared. And then the square root. Okay? But these steps, you can skip because they're considered quite easy. You can. Or you can just keep them in also, if you prefer. Okay, not wrong to have them. Just be careful with your work. So once you have the length, you get the area. Simple. Practice 12. So here we have an equilateral triangle, side of length 8 cm. Equilateral triangle. So all the sides will be the same length. 8, 8, 8, 8. 8, 8, 8. Oh, okay. 3 8s only. And then find the area. What is that, Aishu? Okay, so this is a sketch of the triangle. Area for triangle, we know only one formula. Next time you learn more. The formula is half times base times height. Well, base is simple. It is just 8. What about the height? We are talking about this perpendicular height. So recap, I'm also teaching a set 1 all these now. For a triangle, if the base over here is 8 cm, you have to be able to identify where the perpendicular height is. If this is the base, you go over to the other point that is not used. The point that is not used is this point. Drop a perpendicular line down. That is the perpendicular height. So if we have a triangle that looks like this, where this is our base, let's say this is 10 cm, then where's the perpendicular height? You go opposite to the point that is not being used. Over here at the top, drop a perpendicular down. Perpendicular down, in this case, you have to extend. So this is our perpendicular height. Okay, so that's our recap. Then for this equilateral triangle, if I drop a perpendicular down, we are going to end up with 2 congruent triangles. It is going to split into 2 equal parts with a 90 degrees over here. It is perpendicular to the base. So now this is 8 cm as well. If you're going to split into 2 equal parts, this must be also 4 cm and 4 cm. So now we focus only on one of our newly created triangles. Over here. Want to find the height? Again, Pythagoras theorem. Square root 8 square minus 4 square. Okay, so that's our height. The teacher over here used x. Okay, let's just be consistent, use x. Doesn't matter, just be consistent. So we have a value, x is square root 48. We don't want to evaluate. Wow, don't be so eager to press and find out what that number is. The number is square root 48. Good enough. Subsequently, area of the triangle, half times the base. The base is 8. And the perpendicular height, square root 48. Get answer, then round off to 3SF. That's all. So this doesn't happen just for equilateral triangles. In fact, for all our isosceles triangles, when you drop a perpendicular down for an isosceles triangle, if you drop a perpendicular line down, you're going to split it into 2 equal parts. And this will be 90 degrees. If your triangle is like this, okay, it's rotated. When you drop a perpendicular down, you're still going to split it into 2 equal parts with a 90 degrees. So this is going to be useful every time you have a similar question. When you drop the perpendicular line down, you're splitting the base into 2 parts, and it forms a 90 degrees. So next, practice 13. So now they tell you that the area of the parallelogram is 420. Parallelogram. What is the formula for area? So recap again. Let's draw a longer one. Okay. So if my parallelogram looks like this, we have 4 different sides. All of them can be the base, but they will have their own corresponding perpendicular height. So generally, we like the horizontal to be the base, huh? So this is the base. Then we go to the opposite side. Remember, for a triangle, we go to the opposite point. And now we go to the opposite side. Because if you think about it, the opposite side has many, many points. Where are they? Where is my word? Okay, here. So the opposite points, we've got so many of them. Any point over here will do. Drop a perpendicular line down to the base. Now, we notice that if I drop a perpendicular line down, it's going to go beyond the base. So extend the base up. So this is our perpendicular height. The vertical line that I'm drawing is your perpendicular height. And all these, they are the same. Same perpendicular height. So for the red color base, this will be our perpendicular height. Now, if I choose the diagonal as my base, suppose this is now the base, you go over to the opposite side. Where's the opposite side? Over here. Anywhere on this point. And you drop a perpendicular line down. Perpendicular line down to the base. This is your perpendicular height. All of them have the same. So you can extend. All these will be your perpendicular height. Okay, so this is a recap, huh? How to identify corresponding perpendicular height from the base parallelogram. So if this information, we are going to find the area by just multiplying base times perpendicular height, just like a rectangle. Well, for a rectangle, we only have perpendicular height. So for this parallelogram, they tell us that the area is 420 already. We are given this distance of 35. That would be our base. So then, this parallelogram happens to have the diagonal perpendicular to the base. Happens to be only, and we can now find out this value AC using 420 divided by 35. What's the formula? They didn't write down, So formula area equals to 35 times AC, and this is 420. So AC will be 12 cm. So that's our area. That's our value of AC being 12 cm. And because this is a right angle triangle with a value of 12, I can find the hypotenuse, which is going to be square root of 35 square plus 12 square. And then you can get a perimeter already. Am I going too fast? Okay, two vertical poles. So sketch some diagram, sketch it out yourself. Then you can see whether there are any right angle triangles. The key is always to find the right angle triangles. That's all we have learned so far. So 12 meters, 22 meters, then it's going to be a difference. It's 12 and another 12 over here, total 22. A wire 15 meter long joins the top of the post. Find the horizontal distance between them. So yeah, we're going to end up with a right angle triangle with hypotenuse 15, vertical height of 10 for this triangle only. So the focus is over here. Distance, make sure you write down your 5 SF value, then you round off. The next one, cross section, road tunnel. This is part of a circle, Let me just sketch out the rest of the circle to have a better idea of what it looks like. Okay. Radius 6 meters. So 6 over here. This is 6 as well. Anywhere. Oh, by the way, here also 6 meters. Okay. So that's going to be crucial. The width is 10 meters. So horizontal distance is 10 because we have an isosceles triangle form. Why is it isosceles? It's got two sides of 6 meters. 6 and 6. So isosceles triangle. Isosceles triangle, vertical height is going to split the 10 meters into 5 and 5. In addition, rather to add on, this will be 90 degrees. Okay, so identify the right angle triangle over here. Of course, on the left hand side, it is the exact same triangle. We call it congruent triangles. So the base over here is 5. 5, 6, I can find out this value. Right? 36 minus 25. Answer is 11. Let me square root that, we get the perpendicular height of that triangle. Square root 11. What they want is actually the entire height. So the entire height will be 6 meters, being the radius, plus our square root 11. Answer, round off. So you need to be able to sketch if you cannot just visualize. Do some markings, identify anything, everything that you can. In fact, the process of reading the question partially, and then looking at the diagram and identifying what are the distances that you can find out allows you to foresee what the question is sometimes. (16). So another ladder this time. Vertical wall, foot is 1.4 meters away. So this is the 1.4, then slide down. Okay, let me see. The foot is 1.4 meters away from the wall and it slides. Okay, so this diagram, something wrong already. Okay, so originally we have the triangle in, hang on. Originally we have this triangle, okay? Right angle triangle again. The base will be 1.4. And it reaches a vertical height of 4.8. Then what happens is that it slides down 1.2 meters because not enough friction. Okay, it's going to slide down. So you need to imagine it sliding down. Slide. And it forms the triangle in green. They also mentioned that it's lead down 1.2 meters. So this portion, 1.2 meters. So that's what's happening. Hey, if it slides down 1.2 meters on the top, does it mean that it slides this horizontal distance of 1.2 also? Do you think there's such a relationship? Is this part slide down 1.2 meters? Should this also be 1.2? Something to think about. But if you're not sure, right, then you shouldn't assume. And that's why we use X over here to help us mark out the horizontal distance. Anyway, so the question is how far the foot of the ladder move from its original. So I can bet you that we shouldn't bet. Okay, I can assure you that this wouldn't be 1.2. No, shouldn't be 1.2. So otherwise, just be copying the answer down, right? Okay, so let's find out from our Pythagoras theorem. What other information do we have that is crucial? It is, let's use black color. The length of the ladder remains a constant. The length of the ladder remains a constant. So in both of these triangles, they have the same hypotenuse. We're going to write down the separate equations for both of these triangles. Let us start with the length of the rectangle first, the length of the ladder first. So looking at a yellow triangle, we see that I've got a base 1.4, the vertical height 4.8. So I can get the length of the ladder already. So length of the ladder 5 meters. Nothing special about that. Then now we focus on the green triangle. The length of that rectangle, the length of the ladder is still 5 meters. 5 meters. And now the perpendicular height is 4.8 minus 1.2. 4.8 minus 1.2 is 3.6 meters. Okay, so it is drawn over here. Then the base horizontal distance will be square root 5 square minus 3.6 square. That's our Pythagoras theorem. So it has this exact value of square root 12.04. This distance 12.04. Then to find out how much extra it was, we just take away the original distance of 1.4, get value, and run off. So that's the situation over here. Any questions? Okay. Practice 17. So obtuse triangle. Refresh your memory again, Obtuse means more than 90 degrees, less than 180 degrees. So obtuse angle triangles, they will look like this. Okay, where one of the angle will be more than 90 degrees. But of course, all angles in triangles will be less than 180. So that is the second half of that definition for obtuse is not a concern for a triangle. And we've got the distances as shown, 16.5 and 11. So find the area of the triangle. Area of triangle. Oh, they also gave us the vertical height, 7 cm. So it wasn't stated in the question, but it was stated in the diagram. So half times the base being 11, times the corresponding perpendicular height. Answer. So part B, find the length of BC. BC over here. How to find that length? Okay. So honestly, that was the first time I was looking at this question. Didn't prepare lesson beforehand. But I know that I always must find right angle triangles. I already found the length of, I've got the area, okay, that might not be useful. Then I want the distance of BC. Right angle triangle. This line belongs to two right angle triangles. First, over here. At the same time, it belongs to this right angle triangle. If I can find the two lengths of any of those two triangles, I should be able to find the third side, because that's how the Pythagoras theorem works. So I'm going to observe my yellow triangle first. So red line, that's what I want to find. Yellow triangle first. In order to find the red distance, I need the distance from C to D, which I don't have. Cannot work already. I also require the distance from B to D, which I also don't have. So it doesn't work. Okay. Let me try the other triangle in green. I need the horizontal and the vertical distance. I've got the vertical distance already. Okay, very good. But I need the horizontal distance, B to that whatever that point is. I don't have it. But is it something that I can find? Because right now this looks a little easier than the yellow triangle, which may or may not be possible. But right now this green one looks more possible. And I have just realized that I need this distance in order to find the distance of B to C. Okay, so now that's my new objective, finding that distance. Look out for right angle triangles again. So we have light blue. I realize that this is another right angle triangle. In this new right angle triangle that I just drew, I've got the hypotenuse AC 16.5. Oh, I've got the perpendicular distance at 7, which means I can find the horizontal distance. Pythagoras theorem. Okay, so I'm going to call this point. Let's call this point A, B, C, D. Let's call this X. I now want to find the distance of AX. Then I minus away AB, which is 11. And then I can find that unknown distance of BX. From there, using Pythagoras theorem again, I can find the distance of BC. Okay, so let's check. AX has a distance of square root 16.5 square minus 7 square. Okay, so I want to leave it as the exact value. Square root of 223.25. That is AX. Then my distance of BX will be square root 223.25. Take away 11. Okay, BX found already. Then the distance BC. BC must be square root of the sum of the squares of BX. So whatever BX is, I'm going to square it. BX has a value of square root 223.25 minus 11. I'm going to square this. I'm going to add that to 7 squared. So early on, I had my 223.25 in my calculator already. Don't remove it yet. Okay, so that value, this square root only lasts until the 0.25. Okay, so square root this minus 11 square it plus 49 and square the value. So I get 8.033 cm. BC. Let's check. 8.033. Okay, so correct. So round off 8.03 cm. I'm not sure if this teacher did the same thing. Oh, this teacher did something else. They used the area of the triangle from part A to find that perpendicular distance B to D. Then what did they do? BC 7 square. What did they get 7? BC. Okay, let me pause this. I'm just trying to understand